Okay, so here we go. So we're going to recap about the Pythagorean theorem first. And so the Pythagorean theorem states that the sum of the squares of the legs is equal to the square of the hypotenuse in a right triangle. And so I'm going to quickly kind of do our little right triangle that we've dealt with since, what, Tuesday, I guess? So have my two legs drawn, and then I'm going to connect the two legs and create my hypotenuse. Okay, and so we know that the side that's diagonal from the right triangle is my C, or my hypotenuse. Okay, and then I have my leg A, and then my leg B. Okay, so we know that if I square my leg A and then I square my leg B, if it's a right triangle, it should equal the square of C. Okay, so that's mainly what the Pythagorean theorem is. And so today we're going to be looking at the Pythagorean theorem and its converse. And that means that we're going to see if we're given three lengths or three side lengths, can we determine whether or not those side lengths are actually a part of a right triangle. So, and we're going to use the Pythagorean theorem in order to do that. Okay, so let's look at, as far as the Pythagorean theorem and its converse, we'll look at this and talk about how would I figure out, or how would I use the Pythagorean theorem to determine if three side lengths are the converse, or they are a right triangle. So the converse of the Pythagorean theorem involves testing three sides to determine if they form a right triangle by substituting the three given values into a squared plus b squared equals c squared. Okay, and this is an important thing to remember. When you're substituting, know that the longest side length always is going to be C. And that means the largest number that's given to you, make sure you understand that that's always going to be C. Okay? And just by a general rule, the shortest leg will be A, and then of course the last side length will be B. Okay? So if we substitute those three values that are given, and both sides of the Pythagorean theorem is true, the statement is true, that means that this side of the equation and this side of the equation, if it's true, that means that this is a right triangle. Okay? And I know that seems all in theory, so let's look at an example, and we'll kind of put it in practice. Okay? So let's look at this one, our example 1. So we have these two, and it's actually example 1 and 2. Okay, so we'll do A first. And what I always want to suggest to you guys to do like a little table where you have A and then B and C. And what you're going to do is assign one of the three values that are given, or side lengths are given. You're going to assign them as A, B, or C. And which number will always be C? The longest or the largest number. So which one out of these three are the largest number?
34 inches.
34 inches. So 34 will be C. And then when we look at, now we want to assign A and B. So what's the smallest?
16.
16. And then, of course, the only one that's left is 30. Excellent. It's 30. Okay, so now we've assigned our A, B, and C. So this is always going to be the first thing that you want to do, assign your A, B, and C. Okay, so I'll put assign here, assign your A, B, and C. Okay, so now we've done that, and just like always, now we want to write our Pythagorean theorem down. So we have A squared plus B squared equals C squared. So once we've written down our formula, now we want to look at our table and we want to now substitute in the values of A, B, and C. So for A, we said it's 16, so we have 16 squared plus, we said 30 squared, so B is 30, and we square it, and then C is 34, so we did our substitutions. Okay, so now we're going to use our little friend called the calculator to square all three of these numbers. Okay, so 16 squared is how much? 256 plus, what's 30 squared? 900 equals 56. Okay, so Ms. Thomas wrote kind of big, so I'm going to have to do a little arrow going this way. Okay, so now add 256 plus 900. What is, it's 1,000?
1,156.
Okay, excellent, and so then we have equals 1,156. Is that statement true?
Yes.
Yes, it is true, and because it's true, then that means this is a what?
Right angle.
It's a right triangle. Excellent. Excellent. It's a right triangle. Okay? So let's do this other one the same way we just did that one. We'll do a little thing to separate them. Okay? So the good thing, so now first thing we want to do is what? Assign our A, our B, and our C. And these first two examples, they're really nice and clean because what? They're already in what? From smallest to largest, right? So we can actually just fill those in, but we always know that C is always what? The longest side or the largest number. And then we have for A, we have 14, and then for B is left is 49. Okay, so now we're going to what? Write our Pythagorean theorem down. A squared plus B squared equals C squared. Excellent, Tia. Okay, so now now we need to substitute. Okay, so I'm going to put 2 over here. I didn't do it for this one, but I'm going to do a little side note. We want to substitute for step 2. So A is equal to 14. So we have 14 squared. Then B is 49, so that's 49 squared. And then the last one, C, is, 51 squared. So I need some help again. 14 squared?
196.
196?
Yes.
Plus, what's 49 squared?
2,401.
401. And then 51 squared?
2,601.
2,601. So what is, when we add 196 and 2,401?
2,597.
Thank you, 2,597. I'll write it kind of under here because it's not showing up really good. And then the other side is 2,601. So is this statement true?
No.
No, it is not true. So you put a little cross. That means that 2,597 is not equal to 2,601. So this is false. So that means what? It is not a right triangle. Ooh, I'm running out of space. There we go. Not a right triangle. Okay? All is well? Okay, so let's do this. So we're going to go on to our last example.